In this lesson, we're going to continue to work on the cosmetic ridges on the back side of the helmet and then move forward. We've already trimmed out an area for the ridges, and you can see from the sketch that we're trying to create a four-sided boundary surface. With the sketch that will close up the opening, that will be one side. This will be two, this will be three, and this will be four. This will fit into the scheme that most CAD modelers want to see of having four-sided surfaces. So let's continue to roll down the model a little bit. We've got sketch 10, which is the ridges sketch. Let's just rename this. And we can create this boundary surface. Let me create it from scratch here. Direction 1 will be this sketch. The other direction 1 will be this edge. Now we want to set up the end conditions for these. We can do that from these flags that fly out. What I want to do here is make this go curvature to face. This is going to make sure that as this surface goes across this edge, that it's smooth to the surface on the other side. This sketch, I'm going to set normal to profile because as it goes across the sketch in the back, it needs to be tangent to the mirror of itself. And direction 2, going to be this edge on top, which again should be curvature to face. Now, SOLIDWORKS is going to give us a little warning here. The guide or profile curve's curvature at its endpoint does not match the curvature of the surface it touches. That may seem like an inscrutable comment, but it really does mean something. What it means is that down here in the sketch, this sketch was only tangent to the edge on the other side. So if this edge is only tangent, then coming across here will not be able to be curvature continuous. So I'm going to relax this constraint a little bit to be tangency to face. Let's do this again on the other side. And again, make this tangency to face rather than try to push it to curvature continuity. Now notice what's happening as these ridges travel through this feature is that they're getting slightly diminished until they stop existing at that edge. You can control this with connectors that we talked about before. So I can right-click, add connector, right-click up here and add another connector. Now I want to show you some of the things that can happen if you try to push a connector too far. You take this and push it up here, and then take this one and push it up right behind it. Very often you'll get a little pucker in the part right down about this area. Let's try to push it even farther. Well, in this case, it's working out pretty well. So you can influence the shape nicely by using these connectors. And remember that you cannot use the connectors if you have the selection manager active. For whatever reason, SOLIDWORKS doesn't allow you to show connectors and the connection manager at the same time. So if you want to push these ridges in a certain direction, connectors would be the way to do that. Now let me delete this since we already have a feature that accomplishes that. Now we'll move on to the next feature that we're going to create, which is a little mouth vent. And the mouth vent is going to be slightly inset from the main surface. And this offset is going to reveal the problem that we talked about earlier with degeneracies. So if I roll down this surface offset, it looks like it's created a nice offset from the original surface. It didn't offset around here because notice we've got the light blue edges, means that these surfaces are not knit together. So these are three separate surface bodies. The main surface body that we started with, this ridges surface body, and the offset surface body are all three separate at this point. But what I want to look at here is not even something that's related to what we're doing, but it definitely could affect what we're doing. Notice there's this small notch at the top of the offset surface. This comes from the degeneracy that we created on our original model. Remember I said when you have three sketches that come together at a point, it creates a zero-length side, which is called a degeneracy. The curvature around that point has a tendency to get a little out of hand sometimes. So when an offset is created from it, the offset cannot be created correctly. So in this case, SOLIDWORKS has left out that area altogether just so it can create the feature. Very often, if you were to try to create a shell feature from a body that had a degeneracy or try to put a fillet across that edge, those sort of things would fail. So fortunately, for what we're doing here, we're going to trim out that area, and all we're really going to use is the area down in here. And we'll deal with the degeneracy later, which I mentioned before. So let's continue rolling down. This sketch is going to help us trim out the mouth vent. Here it's trimmed out the section of the main helmet. And now I'm going to use a special kind of surface in order to figure out which area we need to remove from that offset surface. And this is a ruled surface. Ruled surface can be very important, especially in plastics modeling. What this is doing is it's creating a surface that has a special relationship to the geometry around it. First, let's edit the ruled surface to see how it was created. Ruled surface can be created with one of 5 settings. The first is tangent to the surface, and we don't need this new surface to be tangent around here. The second that we used was called normal to surface, and that's essentially perpendicular. That was the option that we used. If we wanted to create a perpendicular cut on the main surface, the normal to surface ruled surface is how that would be created. Tapered to vector is something that you can use if you have to create something with specific draft on it. And perpendicular to vector is another special situation that we'll talk about later. So with that ruled surface created, the next step is to trim out the section of the offset that we need. And you see what this trim feature has done is it got rid of everything on the inside of the offset that we didn't need. And it also got rid of the excess on the ruled surface that we didn't need. So let me just step you through that to show you how that happens. In this case, it's a mutual trim. The surfaces are the ruled surface and the offset surface. Let's select remove selections. And so anything that's in this box is what's going to be discarded. The first thing I need to remove is the excess from the ruled surface and the excess from the offset surface. So when you create a mutual trim, the mutual trim merges together the two surface bodies involved. In this case, the ruled surface and the offset surface are merged together, but the ruled surface is not merged together with the main boundary surface. You can see that because we have a dark edge in here and we have a light blue edge up here. We'll come through later and merge together all the surfaces that we need to put together in a step or two. Okay, so now we've got a front vent and a back set of ridges. Get rid of the extra trim that we created here. And this final feature I want to look at in this lesson is a knit. I'm just going to roll back the knit and show you what we've got. We've got 3 surface bodies. The boundary surface for the ridges, the main surface for the helmet, and the combination ruled surface and offset surface for the mouth vent. We want to join all these together. If we were working with solid bodies, we would use a combine command. But surface bodies can't be put together with combine. What we use in surface bodies is the knit command. I'll activate knit, select the main surface, select the ridge surface, and select the vent surface, and then hit the right mouse button to accept. There are some other options in here which you need to pay attention to. The gap control is one of these things. If you see a gap that shows up in the list, it's a good idea to just click on it before you hit the green check. If you leave a gap in knit surfaces, it's likely to cause you problems later on. This is one of those things that you've got to watch. So we'll click on the green check, and now we're good. If we zoom in here, we notice that all the light blue edges are gone. And if we zoom into the back, you'll notice there's a special condition. Notice that this edge, when I move my cursor away, is using a phantom edge. That's because I have a setting set under View, Display, Tangent Edges as Phantom. This is a setting that can be saved with your templates, and I think it just makes it a lot nicer and easier to tell when SOLIDWORKS thinks that your edges are tangent. Any edge like this really should be nice and tangent. In fact, this one at the end should also be tangent. These edges are not tangent because remember we created a sharp corner there, and that sharp corner continues down until it meets the end of the feature.